Can everyone hear me? So this is what Lotfi looked like in his office in the mid-1990s when I prepared very hard to ask orals committee and my PhD committee. And I had studied an enormous amount of fuzzy logic going in there. I was working on my doctorate in human vision, specifically edge detection, spatial vision, and perceptual organization with applications. And my first meeting with him, I met a brilliant scientist who had perfected Socratic questioning. And he didn't ask me about fuzzy logic. Instead, he took what you can see was a series of convolution, how we were studying edges, transduction, and at the time, we were trying to understand how these types of convolution neural nets get formed into the snake-type pattern that you see on the far left. And he didn't ask me anything about that. Instead, he asked me, what is an edge? We discussed it for quite a long time. We discussed what an edge is at the corner of your nose, what is an edge when you go in very close in size, what is an edge if somebody draws a cartoon of a nose. He actually asked me what the edge of my nose would be, and what would be, and we talked about it, and that became something that I actually worked on for 12 years. So let's look at it at the time. At the time in computer vision, multi-resolution edge detection was a difficult problem. John Canny here at Berkeley came up with one of the best. I'm showing you here on the left a solution. This is one of the best. And you can see that it has some problems. There's edge fragments. There's spurious edges. It's an ill-posed problem. So there is no unique solution. And the answer to Lotfi's question as to what an edge was actually quite difficult to answer. So I want to just take an aside and talk about the matter of using the Socratic method of truth. So when Lotfi and I first talked about it, of course we talked about probability. And with probability, we were interested in the occurrence of an event or your subjective belief about the occurrence of an event. Boolean truth values. The events had to be mutually exclusive, and of course, so that was what we had at the time. And once we introduced fuzzy uncertainty, it meant that the events no longer had to be mutually exclusive. So if an edge detector, either in human or computer vision, detected something that might be an edge, it could be partially true or it could be partially true that it was not an edge. The definition space did not have to be mutually exclusive. And what was fantastic is that if you took the intersection of a fuzzy set of possible edges and its complement, you got the degree of uncertainty an edge would be defined. Now, my dissertation specifically focused on using Gestalt laws of psychology to understand this. And when I first met Lotfi, he said he really wanted to see fuzzy logic applied to psychology. And so that's what we did. If you look on the book continuation, it just means those little edge, I'm showing you some Gabors, they move in a nice, clean manner. Proximity is the distance between these detectors or convolution kernels, and continuity has to do with alignment, how far out or similar. Now, Lotfi was brilliant at introducing people. And one of the things that he did is he introduced me to the work of his other student who got his PhD in 1999. And his technology became the basis for barcode detection and technologies. Now, the key insight that his student with Lotfi had was the idea of using a higher level of understanding, in this case, barcode grammar, to make a decision about how to threshold the possibility. I'm not going to go into the details because we're short on time, but this became the answer, I basically adapted Theo Plavidis' work for my own methodology, and it became the basis of my doctorate. And also Paraview Corporation, which at its peak became 14% automatic background removal. Now, though I'm sorry, I just missed something that was very important. The substitution, what the barcode scanner did is it used barcode scanner to adapt to thresholds. What I ended up grammar of Gestalt psychology to make a decision as to how to adjust the thresholds in this detection process. So I basically did a substitution of the two techniques, and that worked. Now, though I had a solution, and though it was commercially, it didn't satisfy Lotfi's Socratic questioning, because I had not gotten to the meaning of an edge. And I'd like to just also remind, and I think everyone here knows about his work on information as restriction. And one of the key concepts, certainty as to how something is defined. You can have uncertainty as to degree of truth. You can have uncertainty as to a perception. And most important, you can have uncertainty as to other minds. Now, what does that mean? That means that if all of the minds in this room think that we all receive the same sensory information, we have no understanding of how uncertain the representation is within each person's mind. So that is another type of uncertainty that has to be taken into account. I read uncertainty in Lotfi's 1913 paper. He refers to it as perceptual uncertainty with I can't quite get the word. Granulated is a better word to use. Precisely granulated and unprecipitated, I got it, for something in the other mind problem. So after puzzling over this, I read the book by Abbott on Flatland. Now, Flatland contains a fiction in which a square lives in a two-dimensional universe. This two-dimensional square encounters a sphere. The sphere is in a three-dimensional universe and wants to communicate with the square. So what does the square see? Well, when the sphere enters the plane in which the square is living, it sees a dot. It moves through the plane. It sees part of a circle. The edges of the circle are a little bit less in luminance. The circle gets larger. And then as the sphere moves through, it shrinks again to a single dot. And it occurred to me that for all this time, the meaning of an edge in a two-dimensional space. And maybe what I needed to do was go to a higher dimensional space. And that's what I did. So in order to answer the question, I took 12 years of work of what is the meaning of an edge. I had to add a fifth dimension to vision. Now, in this case, you have the standard two-dimensional flatland, horizontal and vertical position. You have depth perception, which we all know from 3D movies. You have time. And the fifth dimension is contextual abstraction. And this was something that Lotfi talked about quite a bit. Text can influence meaning. And in this photograph here, you're seeing that the greatest level of abstraction is the whole image. And then the foreground is a little bit less abstract. And then a single element is less abstract than that. And I call these spatial taxons in space. They're taxometric. They're categorical variables. They do not differ dimensionally on a continuous axis. And there's quite a bit of research I've done in human vision to show that that is the case. So I just want to, I gave you this example as a cartoon. I just want to, here's the whole image. So this is at a maximal level of abstraction. This is the foreground. So now you're at a lower level of abstraction. Now you're looking at just the ladybug. So you're at an even lower level of abstraction. And now you're looking at just the head of the ladybug. This is what a perceptual scene taxonomy looks like. I know we're short of time, so I'm going to not go through this very carefully, but you can see that it becomes a bilateral tree structure. The levels are crisp, but the definitions of the spatial taxons and the methodologies for determining them are fuzzy. So the Gestalt rule analysis is fuzzy, but you defuzzify to get each spatial taxon and its complement. This is a formal definition. I'll leave that for later. And then I want to give you an answer. So fourth on computer vision. And he says we would like edges to be associated with change. It is hard to define precisely the changes we would like to mark. Now we have an answer. Using some of the scene organization hierarchies that resulted with some of my work with Lotfi Zadeh, and using things from psychology, that edges must be attached to a spatial taxon. Using neuroscience, I gave a talk at Johns Hopkins in which they discovered that in V2, proto-edge in neuroscience were showing up regardless of whether or not you had input. So humans have a way of finding these edges. We can now define an edge as the boundary of a spatial taxon at a level of abstraction. Define an edge if you also specify which level of abstraction that is. Now, this leads to the power of the Socratic method, because by focusing on meaning, by focusing on truth, and trying to unearth the truth, realized that the same convolution kernels that we were using all across computer vision were actually telling us two different things. They were telling us what an edge was, and an edge is the boundary of a spatial taxon, but they were often shaped from edges. So the spurious information that we were getting, what was considered noise, can now be defined as texture. And so what that looks like is now we have a dichotomy. Notice how each level of abstraction, where on the upper left we have the boundary of an edge, and everything within that is a texture. On the left we have the boundary of the next level of abstraction of that spatial taxon, and everything on the right is, and on the left we now have just the head of that ladybug, and everything on the right is texture. Now, I left this in. I know that we're short on time, but I just wanted, there was a couple of different people here who talked about semantics, and I want to remind us of the 48 definition of information theory, in which he talked about the fundamental problem of reproducing a signal across a network. And when he defined that problem, he specified that the semantic aspects of the communication engineering problem. Now, if you look at Lotfi Zadeh's 1913 paper, he distinguishes his definition of information from the Shannon information theory. And he says that information is restriction. And what type of restriction are we looking at? Well, that we found in spatial taxonomies, those are restrictions. That is information. And in fact, once you look at levels of abstraction, then the information that's going across a signal just pixel-wise is no longer sufficient for calculating of entropy. Of information, and a entropy-based definition of entropy, because you have to look at the correlations between the layers of the spatial taxons. And if you look at some work from Tironi and Koch that came out of Caltech, where they, in this case, integrated information theory, in which they point out the issue of the phenomenology, which is Lotfi Zadeh's other mind, which is specifically the fact that each human being has an experience within their own mind that may or may not be, even though they're getting the same information. So I miss them. And I was blessed to have a person who tutored me, who asked me questions, who inspired me. And as everyone else here has said, helped me get through my dissertation as a single mother. And that was hard to do. And if it wasn't for the support and the adaptation and the encouragement, I wouldn't have done it. So, thank you.
Yeah, I download AMD's OpenCL tool.
Mm-hmm.
They have lots of examples on two-dimensional image.
Yes.
Yeah, but they use like iPhone.
Yes.
In your case, you have to have different sensor, camera.
No.
And so...
No, you don't.
You define the age. Is this point, is this pixel on the age? They ask that kind of question.
Yes.
Is this on the age? But actually, you are asking, is this group of pixel is on the edge?
Yes.
Yeah. In that case, you have to define the, I think somehow, all this feed to my recognition problem, like if I want to add this feature, then I have more accuracy of recognition. And if I just take in the average color of the pixel.
So the accuracy of the information when you include spatial taxons is enormous. Because what you can do, you can see this in the face detection algorithm. So with my first company, Paraview Corporation, it is the 7th most used face detection algorithm. It's used very heavily in China. And one of the reasons is instead of looking at just a single spatial taxon of a face, it looks at the relative positions of the spatial taxons, and it can calculate the fractal dimension of each one of the edges. So it can distinguish between the fractal dimension of your hair, the fractal dimension of your eyelid and eyelashes. Now, in earlier work, I presented at 2014, I've presented several papers. I actually show how to do this. So the Paraview Corporation natural image processing goes through and shows how to pull apart these different understand spatial taxons. But my more recent work shows how to implement fuzzy inference to make decisions. You actually have to use non-monotonic logic, so it's a little bit deep to do. But it shows how to entail various psychological properties, make a guess spatial taxon is.
Question I want to ask is, do you define the age membership function beforehand?
I require, so I'm hard on this, I require the spatial taxonomy beforehand. So I require, and then the decision is now, it's been operationalized into a two-class inference problem. So does this pixel belong to the spatial taxon at this level of abstraction or the background? And then you do it recursively.
Okay, I think in the interest of time, sorry.
We can talk more.
Yeah, we can talk. So, okay, so let's thank the speaker once again. Okay, and.